So this next problem, we're being asked to calculate the unit weight of a material given the mass and volume of an object. So we're told a brass cylinder, it's got a diameter of 100 mil, a length of 200 mil, and the mass of the cylinder is 13.7 kilograms, and it wants to know what the unit weight is. Okay, so where to start? We'll start by writing down the formula. This is just thinking. I'll just write it in green to show it's just what I'm thinking about. It might be something you write at the side. So we know that unit weight is equal to the weight of an object divided by its volume. So we're going to have to figure out the weight of this brass cylinder because at the moment we've been given mass, and we're going to have to figure out the volume of the cylinder. Start with the easy one first. We know that weight is equal to mass times acceleration due to gravity. Let's just write down what we know and get our units right before we start. So we know that the mass is equal to 13.7 kilograms, but we have been asked at the end of the day to give the unit weight in kilonewtons per meters cubed. That's reasonable enough. Let's just leave it as kilograms for now. And then we know that gravity. Now we've got to think about, are we just using approximate or do we use the exact value or relatively exact value of gravity here? So we've been given the mass as 13.7 kilograms, so it's three significant figures. So we want to have an answer that's pretty accurate. So we want to use the 9.81. So 9.81 meters per second squared. Let's put those in. So that's going to be 13.7 kilograms for the mass times acceleration due to gravity is 9.81 meters per second squared. And if you put those in, you're going to get a weight of 0.13, oh, sorry, 134, skipping ahead, 134 newtons. Now what I'm doing is I'm thinking ahead again. So in the final answer, we want kilonewtons per meter cubed. At the moment, we've got newtons. So just to keep things simple later, I'm going to convert that to kilonewtons now. So there's 1,000 newtons in a kilonewton. So 134 newtons must be 0.134 kilonewtons. So I'm doing that because I know my answer needs to be in kilonewtons per meter cubed. So we've now got the weight. We need to figure out the volume. So I usually remember the volume of any prism is just the area of its end times its length. If you can't remember, Google it. But if you Google anything for engineering, just make sure you've checked your answers on a few different sites to make sure you haven't got something incorrect. And so the volume is equal to cross-sectional area times height. Now the area is a circle in the case of a cylinder. Usually in engineering, so in school you usually write this as pi r squared. In engineering you usually have the diameter of objects, not their radius, because you measure it with a pair of calipers or something like that. So usually you know the diameter. So the equation we usually use for a circle is 1/4 pi times diameter squared. And then we're going to times that by the height to get the volume of this cylinder. So it's 1/4 times pi times. Now, again, I'm thinking forward. We're going to need meters cubed in the end. So just to make things easy, I'm going to convert these dimensions to meters now to save me doing it later. So that's going to be 0.1 squared times 0.2 meters. Okay, so this is in millimeters, 1,000 millimeters in a meter. So I'm going to get 0.1 meters times 0.2 meters. And then if you do that calc and stick it in your calculator, you're going to find that the volume is 0.00157 meters cubed. Now you could write this in scientific notation if you want, it doesn't really matter. So when you're doing that, you just do, it's going to move the decimal point 1, 2, 3 places. So that would be equivalent to 1.57 times 10 to the negative 3 meters cubed. But I'm happy enough just write it out in long form. So we've got our volume now, we've got the weight, so we've got everything we need to calculate the unit weight. So the unit weight is going to be equal to weight divided by volume, so 0.134 kilonewtons divided by 0.00157 meters cubed. and put that in the calculator, you're going to get a unit weight of 85.3 kilonewtons per meter cubed. As always, you want to try and think, is that sensible? So 85.3 kilonewtons per meter cubed. Now, I haven't memorized the unit weight of brass, but I do, or it's worth remembering the unit weight of steel. So for steel, I don't really actually remember the unit weight, I remember the density, and it's 7850 kilograms per meter cubed, roughly, is the density of steel. Now, that's the same as 7.85 tons per meter cubed, which is approximately equal to 78.5 kilonewtons per meter cubed. So just using all these conversions that we've been using so far. So I know steel is 78.5 kilonewtons per meter cubed. I know brass is a fairly dense material, unlike aluminium. Brass is pretty heavy, and so that looks like a sensible answer. So we'll write in full. Density of brass is equal to, it's not a density, it's a unit weight. Unit weight of brass is equal to 85.3 kilonewtons per meter cubed. And we'll move along to the next one.